Hello and welcome. I am Bharat. I'm a math educator. I have done MSc in mathematics from IIT Madras. I live in Palampur, Himachal Pradesh, and I have students from different countries, different backgrounds, different class, different schools, and doing different courses. My passion is to teach mathematics, and the mathematics I teach is more visual, more experiential, um, where we discover the concept there, we feel the concept there, we experiment, we estimate, we involve in the process there, and I believe in the stress-free mathematics, but with better results and a strong foundation for a future in mathematical sciences and sciences in general. Uh, so to showcase my way of doing mathematics, I am doing a small proof of Pythagoras theorem, and this proof is very famous and very easy proof that you haven't seen in the books, but this is one of the very interesting proof of Pythagoras theorem. So to start doing that, to prove the Pythagoras theorem, we need an element, and this is what? This is a right angle triangle. So let's draw a right angle triangle. So here I draw a right angle triangle there. So this is a right angle triangle with long height and small base. I'm making this just to make the difference between the base and the height clear. Otherwise it's a very general right angle triangle. So B is the base here, A is the height, and C is the hypotenuse, and the bottom corner is 90 degree, and the side in opposite to the 90 degree is hypotenuse. And what we are going to prove here, we are going to prove is to prove is to the square of the hypotenuse is equal to the sum of the squares of the height and the square of the base. So how can we prove this? So let's copy this, a congruent copy of this right angle triangle, and paste it at the top vertex of the triangle such a way such that you will see that the base comes here and the height comes in the horizontal position, right? So this is B, this is A, and this is C, right? Now our task is to find the angle. So let's find the angle. Which angle I'm talking about? This is this angle. What is this question marked angle? So let's start from the by assuming that let's say that the angle between B and C is theta. A and C would be obviously 90 degree minus theta, and B and C would be again, it's a congruent copy of the triangle before, so it is again theta there, and A and C is 90 degree minus theta. So how much is the angle there? So B and A here are making linear pair, right? They are joined such a way that they make a linear pair. Theta and 90 degree minus theta, theta plus 90 degree minus theta. If we add these two angles together, we get 90 degrees. And in a linear pair, if one of the angle is 90 degrees, then the other would be obviously 90 degrees. So this question marked angle is a 90 degree angle. So the side C and C, both of these sides are perpendicular to each other, and I do another construction here to close this figure, to make it a closed figure here. So the pattern of the proof would appear here. So it's now a quadrilateral which has four sides. Three we know, the base is B and the height is the sum of B and A together, B plus A, and top side is A, and we don't know the blue one, so we don't need to find that side also. So how can we find the relationship between the squares here? So whenever you are stuck with such situation, just look at what is the thing that connects everything, the thing which is the connection to all the patterns appearing there, all the perspective maybe uh, not varying if you change the position of the object, uh, or the situation of the object, or the perspective you are looking at the object. So here I see the area doesn't change, whatever method I find the area, whatever orientation of the figure is. So area is the invariant quantity, it's not varying here. So looking at the figure, there are many methods of finding the area. So we find the area by some of the method and see what happens. So uh, to find the area, we see that this is a particular kind of quadrilateral. What kind of quadrilateral? You can see that the 90 degree here and the 90 degree, if you see, is also here, right? So these two 90 degrees are on the same line. So these two lines are parallel. Which lines I am saying? Line segments B and A. These are parallel to each other because they are perpendicular to this length B plus A. So in a quadrilateral, if there is a pair of parallel line segments, pair of parallel sides, it's a trapezium. So this is a trapezium actually, right? Trapezium. So to find the area of the trapezium, what we do, we sum the parallel sides, that is A plus B, multiply by the height, that is again A plus B, and divide by 2, right? And in how to find the area by using a different method. So you see the given quadrilateral is in broken into three triangles. There are three triangles involved here. So this is triangle 1, second, and the copy of the triangle 1 is the third triangle. So the area of triangle is base times height divided by 2. So let's find the area of the first triangle. The base is B and the height is A. So this is equal to base times height divided by 2. Then the area of the second triangle is C times C divided by 2. And the area of the third triangle is again B times A divided by 2. Right? And we see that each term in the equation, left and right hand side, has 2 in the denominator. So we can remove this denominator by multiplying the equation by 2. So when we multiply, the 2 gets removed and it becomes A plus B times A plus B is equal to B times A plus C times C can be written as C squared plus B times A. And now I have A plus B times A plus B. So if you know the identity, you can write this as a result there. But if you don't know the identity, don't bother about that. We can find this by a very visual method. So just make a rectangle there. A rectangle can also be used to find the area, right? And area means you can multiply two quantities there. So how can you multiply A plus B times A plus B? We pick up one of the sides as A and the other portion would be B, right? So this is broken into two parts. Similarly, the other part would be A times B, right? So let's use this area method to evaluate the identity A plus B times A plus B or A plus B whole square. So A times A is obviously A squared, A times B is AB, and B times A is BA, but we know that multiplication is commutative. So we can reverse the order of multiplication there. So B times A becomes BA becomes AB, right? So this becomes AB again, and B times B is obviously B squared, right? Easy. So here we have 4 terms, but we see 2 terms are exactly same, equal to each other. So we club the similar terms, same terms together. So it becomes A squared plus 2AB plus B squared. So let's write it below the A plus B times A plus B. A squared plus 2AB plus B squared, right? I got the left hand side. Now let's write the right hand side. So here again I have BA plus C squared plus BA, and there are 2 BAs here, so I write 2 times BA, 2BA, and 2BA can also be written as 2AB. So let's write 2AB plus C squared. So 2AB is there, um, and on both the sides. So the same quantity is both the sides, so we can remove this quantity, right? This is now a very redundant quantity. So let's remove this 2ab from both sides, and I am left with a squared, b squared, and c squared. And rewriting the equation, I get a squared plus b squared is equal to c squared, which is the desired result, and which proves this theorem, Pythagoras theorem. There, that is the square of the hypotenuse is equal to the sum of the squares of the perpendicular sides, the height and the base, right? Squaring the base, squaring the height, and adding them together. And I just want to to say it again, that this proof was done by James Garfield. He was the 20th president of United States, and he was a military general also. But he used to do the mathematics in his spare time, and he got this very beautiful, nice proof. So I think you I hope that you liked this proof, enjoyed it, and see you soon. All the best. Have a nice day.